Hello Eng 1060. In this video, I will cover logical operators. In the previous video, we saw how relational operators can be used to check if a statement is either true or false. As an example, if we specified a scalar a is equal to 5, we can get MATLAB to return either a true or false value by typing in a greater than 2. Logical operators allow us to combine multiple relational operators. As an example, we can check whether a is greater than 2 but also less than 10. The logical operators in MATLAB are given by AND, which is the ampersand symbol, OR, which is the vertical line symbol, and NOT, which is the tilde symbol. So when combining multiple relational operators, we need to consider truth tables. We can read the following tables as follows. Imagine if A was false and B was also false, the result of A and B would be false. If A was false and B was true, the result would still be false. It is only possible for A and B to be true if both A and B are true. This is in contrast to the OR truth tables. If A is false and B is false, then A or B is false. If one of A or B is true, then the result of A or B will also be true. The NOT operator will simply invert from true to false or false to true. Ensure that you understand and are able to create these truth tables. Here I'll go through several examples. This statement here is we're checking whether x is between negative pi and pi. In MATLAB, we would write this as x greater than or equal to pi and x less than or equal to pi. Mathematically, you would write this as negative pi less than or equal to x, which is less than or equal to pi. However, this mathematical expression is not recognized in MATLAB in the normal sense, and therefore we need to explicitly write x is greater than negative pi and x is less than or equal to pi. Here is another example using the OR command. We are checking whether the month variable is equal to 3 or 7 or 11. Note that for each case, I must explicitly write month is double equals to a number. I cannot write month is double equals to a vector, as this would not work. And finally, I'm checking whether the month variable is not equal to 3 or 7 or 11. And I'm storing this result into a variable z. So z can either be true, which is 1, or false, which is 0. Logical operators also work on matrices, though you do need to ensure that when you're working between matrices, they must be of the same size. As an example, we have A is equal to 2, 4, 6, 8, and B is equal to 2, 1, 0, negative 1. We can check whether A is greater than 2 and then inverse the results. So A is greater than 2 will give us the result of 0, 1, 1, 1. Inverting this with the tilde will change the true to false and false to true, giving us 1, 0, 0, 0. If we invert this again with the double tilde symbols, then we will recover the original result 0, 1, 1, 1. Here is an example considering two vectors where we have A is not equal to B. This is equal to false, true, true, true. And B is less than or equal to 0. This is equal to false, false, true, true. When considering the AND operator, if one of the results is false, then the entire result will be false. So false and false will give false. True and false still gives false. True and true will give true. And true will give true. You should go through the final example to see whether you recover the same result given by MATLAB. Recall that you can address matrices using logical values, and that the logical function creates a variable with the logical data type. As an example, we have A is equal to 6, 4, 2, 0, negative 2. We can then create an index using the logical function, which will contain zeros and ones. Addressing the A vector with this index will recover the true values, which is the second, third, and fourth elements, which are 4, 2, and 0. This is very handy when you require only data that meet specific conditions. Not all relational conditions need to be checked when using logical operators. And this is an example of unnecessary checking. So we have some index variable which contains a number, and we're checking whether it is less than the length of A and greater than 0. So let's assume that our index variable has a value of 11 and the length of A is equal to 4. Therefore, this statement here is false. So it doesn't matter what the result of the second statement is, because with the AND operator, if one of the conditions is false, then the whole result will be false. This means that there is no point in checking the second condition, as this will only waste time. So we can use something called short circuit operators, which stop and gives a true or false result as soon as possible. There is the short circuit AND operator, which is given by the double ampersand symbol, and the short circuit OR operator, which is given by the double vertical line symbols. With short circuiting ANDs, if we have expression 1 and expression 2, if expression 1 is false, then expression 2 will not be evaluated. It doesn't matter whether this expression is true or whether it is false. The entire result will always be false. You can see this from the truth tables. Likewise, short-circuiting OR operators, if we have expression 1 or expression 2, and expression 1 is found to be true, then expression 2 will not be evaluated. It doesn't matter whether expression 2 is true or false, the result of expression 1 or expression 2 will always be true. This is because if one of the expression is true, then the result of the OR operator will always be true, and you can see this from the truth table. There are some general rules that you should consider when using short circuit logical operators. The first is the short circuit operators only work on scalars and should be used in your if statements. If statements are something that we will learn in a future video. You should use the single and or operators everywhere else. So in summary, in this video we covered logical operators and truth tables. We looked at how to use logicals as indices for matrix addressing. We also covered short-circuiting operators to avoid unnecessary checking. As a final thought for this video, what happens if the logical function isn't used in the following code?